Here in Module 6, we are investigating acids and bases, and we're really going to look a lot at what makes something acidic or basic, but mostly how your body regulates its pH, which is a measure of the acidic or basic environment in a scale that we may be a bit more familiar with. This is a hugely important biochemical process, and it's something that in healthcare really does need to be monitored because if certain chemical quantities are off, that could lead to a change in pH, and knowing how to treat them is a really important and fundamental part of healthcare. In this first video, we're just going to introduce the idea of acids and bases, and we'll take it from there, ending with some healthcare applications. In this module, we're going to be dealing with acids, bases, and buffers. This is a really important topic in healthcare and biochemistry. The acidic environment that a certain organ may be living in is really important to its function, and our bodies are pretty sensitive to even small changes in how much acid or base could be present. It's important that as we look to this, we learn about what causes acidity, what causes basicity, and some basic chemistry that will govern how our bodies are able to regulate these quantities. And so to get started, right, everyday examples of acids and bases, these are a lot of things that we've seen before. So acids are like lemon juice or vinegar, or gastric acid, which is based on HCl, hydrochloric acid in the stomach. HCl, that's its chemical formula. These have some common attributes, right? If you put them into a cut, it's going to burn, and they have a sour type of taste, right? Lemon juice and vinegar aren't that different, and some of that similarity is due to the fact that they're both acids. Bases, baking soda, antacids, household ammonia. Note that two of these, like baking soda and antacid tablets, these are actually solids. They're ionic compounds. It's when they're put into water that they are really showing their activity as bases. The definition, though, and this is really important to keep in mind, right, that there is a chemical definition for what is an acid and what is a base that we're going to look at here. And an acid is something that donates hydrogen ions. So most often this is where we have H+, where you might expect for a positively charged ion to be. We don't really consider acids ionic compounds, and we don't really consider H+ a cation. It's kind of in a class of its own. It's an acid, where if we have a substance that donates hydrogen ions, H+, very importantly not hydrogen altogether, it's H+, it's missing its electron, that we call an acid. And a base is something that accepts hydrogen ions. And in the presence of water, this is almost always from the water itself. And because it is accepting hydrogen ions, it will make OH-. And I suppose an exception to this is something that just dissociates into hydroxide ions. That would be a base as well. The key is that it makes hydroxide in water. And this is the unit that we're going to associate with bases. OH- associated with base, H+ associated with acid. And these may seem like kind of random things that need to be memorized, but we're going to see here in a second that they're really very much related to water. As we're working toward that though, acid, H+, base, OH-. You'll also see proton donor out there in the literature. That's because H+ is literally just a proton, and a base is a proton acceptor. When it accepts that hydrogen ion from water, it leaves us hydroxide, OH-. And so, again, here are some examples of how we see this in practice. We said that HCl is an acid. HCl will dissociate when you put it in water, and it's going to form H+ and Cl-. It's forming H+ when we put it in water, right? HCl is a reactant. It forms H+. A base like sodium hydroxide in water does the same thing. It's going to dissociate as well. NaOH is going to form sodium+, that's not the base. Hydroxide OH-, that's our base. And as we're looking at aqueous solutions, we really want to associate these chemical entities with the idea of acidity and basicity. H+, acid, OH-, base. And I think that a way to really drive this home is what happens if we bring these two together? This is probably something that you've seen before, right? If we bring an acid and a base together, what happens? Do they both exist, or do they like to do something when they see each other? Maybe go ahead and pause here, think about that. What happens when acids and bases run into each other? In other words, H+ plus OH-. Is something going to happen? And could we predict the product of what happens? Maybe you're able to predict the product here, that's great, but if not, I think that perhaps you thought that they like to combine with each other. They cancel each other out. They don't both live together at the same time for the most part. And because when they come together, the positive and the negative charge cancels, we've got two hydrogens and one oxygen, that's H2O. And as we've discussed, water is a really favorable product. Water likes to be formed, and if there's a reaction that can make good old pure water, it tends to occur. H plus and OH minus like to combine into H2O. And this is acid-base neutralization. And when a big amount of H plus sees a big amount of OH minus, they like to make water for the most part. But note that in every solution, there's going to be a little of both H plus and OH minus in water. There's probably going to be a lot of one of those, but always still a little bit of the other. So this reaction doesn't go to like 100% completion. It's like 99.999, 99.999999, right? It's mostly and virtually all going to completion. But there will still be a small but significant amount of both that are present in water. That's just a characteristic of water that's important to keep in mind. We always have a little bit of each H plus and OH minus. Acids have mostly H plus, bases have mostly OH minus. And on the topic of acid-base neutralization, I think this is kind of a challenging topic for students because they cancel out. That sounds great. But it only cancels out almost all the way. The fact that we still have both remaining is a little bit, it feels like a little hand wavy, but please just try to go with it. I think that it explains further chemistry pretty well. If in the meantime it's just like they cancel out, acids mostly H, bases mostly OH, that sounds pretty good. I say HOH, but H plus, OH minus. This neutralization, this is like the paper mache volcano. Maybe we've seen this before. In this case, we bring vinegar, an acid, with baking soda, a base, and they combine. The acids and bases neutralize. That's not what causes the bubbles. The bubbles are CO2, which is a product of the sodium bicarbonate, this should say, baking soda. That's a byproduct of this, but it's driven by the fact that it's forming stable compounds, water, and also, somewhat carbon dioxide.